Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No. We've got a mixture here. Now, Amy's going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you can ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam, Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out, and I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hello, everybody, and welcome to Wednesday Night Math Night. Like Dr. A said, I am Amy Sink, and I am one of the math specialists here at the Learning Liaisons. And I just love what we get to do here at the Learning Liaisons, which is help you be more successful, be more confident, be more competent in your math skills when you're getting ready to take these math exams. So it is just a joy to be here on Wednesdays. I was not here last week because it was my nephew's 18th birthday. I can't believe he's 18. And so we were celebrating him. And this week I have dislocated my shoulder. Yesterday I was teaching a dance class and dislocated my shoulder. And so I've been icing it on and off. I've been taking all the Advil and Tylenol and another pain med they gave me at the orthopedic, and we have to follow up on Friday. So we'll see what happens there. So I just feel like I'm a disaster. I came off of like a week and a half of being sick, and now my shoulder is hurting really bad. But it doesn't affect my ability to write, so we are still here for math night, and I'm just going to let this arm rest while we're doing it. In the comment box, let me know where you're from, what test are you prepping for, and get to know you question. What is your favorite Thanksgiving dish? If you celebrate Thanksgiving, what is your favorite Thanksgiving dish? Like, is it the green beans? Is it the mashed potatoes? Is it the turkey and gravy? I would have to say my favorite is probably I love green bean casserole, and I love stuffing. Stuffing is my favorite. I do have a gluten allergy, and so I always have to make all my own stuff and bring it to Thanksgiving. But I am obsessed with stuffing. I don't know why, but I'm obsessed with it. Mushroom Wellington. I can't say I've ever had that, Hope. I'm coming to your house for Thanksgiving, and I'm going to try that. Sound good? Deal. So Yeah, Thanksgiving is not the best holiday for people with gluten allergies, but we make it work and I try my best and I just make all my own stuff and bring it with me. In the comment box also, as we're working through problems, let me know what you want to see upcoming. Someone posted some problems they wanted to see me go over this week. I did not get a chance to add those into this week's presentation, so I will definitely add those into next week's presentation. So I'll just add next week, and then I'm going to put Facebook problems. So I remember to add those into next week's set of problems. But in the comment box, definitely let me know what you want to see moving forward, what kind of topics, what kinds of questions. If there's a specific question that you're like, I've been really like struggling with this question, let me know in the comment box what you want to see, and I'll be happy to add it to the upcoming week's problem sets. So yeah, let's go ahead and get started with our first problem, y'all. A trapezoid has an area of 325 feet squared. A new trapezoid is created by dilating the original by a factor of 3. What is the area of the new trapezoid? What is the area of the new trapezoid? So the first thing that people are going to do is probably see that we have an area of 325 feet and we're dilating the original by a factor of 3. And so the most common error is going to be that people are going to do 325 times 3. I'm going to use my handy dandy calculator. 325 times 3 is 975. And they're going to say that that's their answer. However, that is not the correct answer. And here's why. Dilation is when we dilate the original linear measurements. So if I have a trapezoid and then I dilate it by a factor of 3, so we'll pretend that this was dilated by a factor of 3. And my original measurements were 10 and 4 and then 5. So the new measurements would be 5 times 3 is 15, 4 times 3 is 12, 10 times 3 is 30. Then when we find the new area of the trapezoid, I'm not multiplying this area times 3 and getting this area because each side multiplied times 3. Which means that my area is actually going to be dilated by a factor of 3 squared, which is 9. So the trapezoid was dilated by a factor of 3, but when we try to figure out what the new area is, we have to take that dilation and square it because area is squared. And so I can now take my previous area of 325, multiply it times 9, and I get 2,925, which is D. So when you're talking about dilation and scale factors, you have to think about, am I dilating the linear, the area, or the volume? And when they give us a scale factor or a dilation factor, it's being applied to the linear measurement. And then if we are looking for the new area or the new volume, we either have to square it or cube it, depending on what we're working with. So that's how you would do dilation and scale factor. Adele, you are so welcome. We love being here. We love helping you. And like I said, let me know in the comment box what you want to see moving forward. It is so weird just talking with one hand. If you've been here for any amount of time, you know that I like to talk with my hands. But given that I can't really move my arm, it's just kind of weird talking with one hand. So yeah, anyways, moving on to problem number 2. Sarah is creating a new exhibit at her local children's museum in the circular exhibit room. The room has a diameter of 72 feet. She wants to create 8 different mini exhibits that all have equal area. To delineate each area, she will use bright, flexible baseboard along the wall that is a different color for each area. If the different colored baseboards cost $3.25 per foot, how much will it cost for each section of baseboard? Use 3.14 for pi. $28.26, $54.76, $91.85, or $183.69. So this is a really thick, wordy problem. In order to solve this, we have to consider the fact that we've got a ton of words here. We have a ton of words here. So we're going to break it down. She's creating a new exhibit in a circular exhibit room. That's really the only piece of information in that first sentence that's helpful. So I know that I have a circular exhibit room. The room has a diameter of 72 feet. Now, when you are solving problems that involve geometry, it's important that we are drawing a picture so we can visually see what we're dealing with. So we have a diameter of 72 feet, which means we go through the center and we touch each edge of the circle. So the diameter is 72 feet. She wants to create 8 different mini exhibits within this exhibit room. And so I'm going to create 8 different exhibits. So I'm going to cut this in half, and then I'm going to cut this in half again, and then I'm going to cut this in half again. So there's my 8 different mini exhibits, and they each have equal area. So the inside is all equal. And that is critical information. To delineate each area, she will use bright, flexible. Well, that was weird. I was literally just talking and like the screen just froze and my computer shut off. And now we're back. And that really hurt. Okay, here I am trying to use both hands. And then I'm like, oh, wow, that hurt. Okay, let me reshare my screen. I don't know where it cut off. Like where, if somebody could comment and let me know where it cut off for you guys, that would be super helpful. Otherwise, I'll just start from the beginning of that problem because this problem is super word heavy. And so I don't want anybody to miss any of the pieces when we're talking about this problem. So we're just reconnecting and then we will get started. Technical difficulties. I love technology. It's my favorite, especially when you're live. Like if you're not live, you're like, okay, I can just delete that section out. But when you're live and technology fails on you, there's not a whole lot you can do other than be like, well, this is life. All right. I don't know why it's not working. Let's see. Let's quit this app and restart. All right, can someone let me know in the comment box where we stopped with that whole problem? All right, let's try this one more time. See if it works. Well. Okay, let's try this. All right, here's what we're going to do. We're going to flip the screen around and we're just going to do it this way. All right, because the mirroring is not working. So we're just going to have to do it old school, which is going to present a problem given that my shoulder is killing me. Okay. Okay. Sarah is creating this new exhibit for her local children's museum in the circular exhibit room. The room has a diameter of 72 feet. She wants to create 8 different mini exhibits that all have equal area. To delineate each area, she will use bright, flexible, for the love. She will use bright, flexible baseboard along the wall that is different color for each area. If the different color baseboards cost $3.25 per foot, how much will it cost for each section of baseboard? Use 3.14 for pi. Okay, so I drew the circular room. I divided it into 8 sections, and I colored in blue here to indicate that like those are the equal sections, equal areas that we have. And there's a diameter of 72 feet. And then to delineate each area, she's using bright, flexible baseboard along the wall. So what that means is that we have like a section of baseboard here, and then 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 a section of baseboard here, and all the way around. And each section is different. And they want to know, the like age-old question at the very end is, how much will it cost for each section of baseboard? So I have to figure out what. Am I figuring out the area? Am I figuring out the, like, what am I figuring out here? I'm not figuring out area because I don't want to know how much carpet I need. That's not what I'm trying to figure out. So what I'm trying to figure out is the perimeter of this circle, or should we call it the circumference? Because in a circle, the perimeter is called the circumference. And so what I need to do is I need to figure out step 1. Okay, so now I'm going to like write some steps out so that we can talk about it. So step 1, find the circumference, because there are multiple steps. Circumference. Step 2 is to figure out, like, divide that circumference by 8, because they don't want to know how much the baseboard is going to cost in all. They want to know how much does each section of baseboard cost. So then I have to divide the circumference by 8, and then I have to figure out the cost, which I'm going to multiply that by the, like, the linear foot, right? So step 1, find the circumference. Step 2, divide it by 8. Step 3, find the cost. So circumference equals 2 pi r. Pi is going to be 3.14. They told us that. So circumference equals 2 times 3.14 times r. What is r? R is going to be our radius. And you're like, well, they didn't give us a radius. You're right. They didn't give us a radius. But what they did give us was a diameter. And a diameter is just double the radius. A radius is half of a diameter. So I can do 72 divided by 2, and that will give me my radius. So I'm going to use my calculator. 72 divided by 2 is 36. So 2 times 3.14 times 36 equals, circumference equals 226.08. So step 1, done. Step 2, divide that by 8. Why did I write all of these steps out? Because when I get into the thick of solving a problem like this, it becomes easy to get lost in the work and not remember my steps. So if I can think about what do I need to do next, then I won't get lost in my work. So if I divide that by 8, that equals 28.26. And then I can multiply that times 3.25. And that gives me $91.85. C. Questions? All right. I'm going to see if I can get this thing to connect because that's really not ideal. So before we move on to the next problem, I'm going to try to connect it one more time. And then if it doesn't work, this is just how we'll do math night tonight. So let's see if it will connect. Yeah, it's not connecting. So we'll just move on to problem 3 so we don't waste any time. Problem number 3. Triangle ABC is an equilateral triangle and triangle CDE is a right triangle. If the length of side AE is 20 units, what is the length of side BD? If the length of side AE is 20 units, what is the length of side BD? So in this kind of problem, the first thing that we like to do is label everything. So I'm going to label what I know. Triangle ABC is an equilateral triangle. They told us that. So that means that this side, and this side are all equal. So if this is 8, then I know this is 8, and I know this is 8. Then they said CDE is a right triangle. Well, they already labeled this angle as a right angle, so I don't need to label that. If the length of side AE is 20 units, so this whole thing is 20. What is the length of side BD? So we want to know this. And what we know is BD is going to equal BC plus CD. And BC is already 8. So I'm going to be doing 8 plus something to get my answer. So that means that it can't be A or B because the whole blue length can't be smaller than 8, A, and it can't equal 8 because I have to add some sort of length here to figure that out. So I know it has to be C or D. So if you are absolutely confused, don't know what to do, don't know how to solve it, then at minimum, you can at least figure it out between 50-50 chance, right? Like you at least have a 50-50 shot of getting it right. Now, how do I actually figure that out? Well, I know that CE is 20 minus 8. I know that CE is going to be 20 because this whole thing is 20, and then minus this 8 right here. Well, 20 minus 8 is 12, so that means that this side is 12. 12 plus 8 is 20. Following? Okay. Now, I don't know what DE is, and I don't know what CD is, but what else do I know about these triangles? What else do I know about these triangles? I know that this is an equilateral triangle, which means these angles are all 60 degrees. I also know that if this angle right here is 60 degrees, then this angle right here is also 60 degrees because they are vertical angles. This is a big geometry lesson for y'all. This one is 60 degrees, So then this one is also 60 degrees. And if this one is 60 degrees, then I know that this one is going to be 30 degrees because this is now a 30, 60, 90. If I didn't know that relationship, I could do 90 plus 60 minus 180 equals 30 because all the angles in a triangle equal 180 degrees, right? So if this is 30, this is 60, this is 90. And for those of you taking the 5 through 9 or the 6 through 12 test, you absolutely should know the 30, 60, 90 degree triangle relationship, which says if X is the side with 30, then this is 2X, and this is X times the square root of 3. The measurement of the sides matches the angles in every 30, 60, 90 triangle. Well, this is across from the 90 degree angle. So 12 is going to be equal to 2X, which means what? X has to equal 6, which means across from the 30 degree angle, that side is going to be 6, and 6 plus 8 is 14. What a fun problem. Tell me that wasn't fun, y'all. Tell me that was not a fun problem. That was such a fun problem. All right, let's go ahead and move on to the problem number 4. If the length of AB of square ABCD is X units, and the length of EF is 2/3 of AD, what is the size of the shaded area? What is the size of the shaded area? Okay, so again, here's another geometry problem. Why are we doing so much geometry? Because someone specifically requested it. So if the length of AB of square ABCD is X units, so the length of AB is X units. This is X. And they told us that this is a square. So that means that this is also X, and this is also X, and this is also X. And the length of EF is 2/3 of AD. So this is 2/3 AD, which is really just 2/3 X, right? What is the size of the shaded area? Well, I know that area of a square equals what? Length times width. Well, really, that's just X times X. So area of the square equals X squared. But we're not finding the area of the square. What we're actually finding is the area of the square minus the area of this triangle. So I'm finding area of the square minus area of the triangle. Well, I have area of the square, and that's X squared. So now I need to find my area of my triangle. Area of the triangle equals 1/2 base times height. What is the base of that triangle? What is the base of that triangle? The base of the triangle is X. So I can replace that. So area equals 1/2 X. And what is the height of the triangle? 2/3 X. simplify that. So area equals 1/2 times 2/3 x squared, because x times x is x squared. And 1/2 times 2/3, these 2's end up canceling out. So this just equals 1/3 x squared. So now if I'm using this formula right here, I can do x squared minus 1/3 x squared. And if I have a whole x squared and I'm subtracting a third x squared, what does that equal? 2/3 x squared, which is D. Questions about that one? Comments, concerns? All right, let's go ahead and move on to the next problem. Ooh, this is a good one. Someone specifically requested a problem like this, and I don't remember who it was, but someone specifically requested a problem for like Math 115, Competency 1. So this one's for you. Okay, a traveler went to Brazil and noticed that on a certain day that 28.19 reals was worth $5 US. Based on this rate of exchange, 100 reals is approximately equal to how many United States dollars? 100 reals is equivalent to approximately how many United States dollars? So in this case, we're doing a conversion rate. And so a lot of times people can figure out how to do conversion rates from like feet to inches, or I don't know, yards to feet or whatever. Hi, Carla, how are you? A lot of information. Is that a question or is that a sorry? Is that a question or is that a concern or is that like a request? Like you want a problem with a lot of information? I'm not understanding what your comment means. So just clarify for me. All right. So a lot of times people can figure out how to do those kinds of conversions. But when it's a conversion with something that they are not familiar with like this, they get frozen and they don't understand. So in this situation, we know that 28.19 equals $5. And they want to know how much 100 reals is. So there's two ways we can solve this. We can set up a proportion. Or we can find out what the unit rate is and then just multiply that by 100. Both of those ways are going to work. So I'm going to actually solve it both ways so that I can show you what that looks like. Okay, so we're going to solve using a proportion first. So if I know that 28.19 reals equals $5, then that means that 100 reals equals X dollars. So if I'm setting up a proportion, I just want my reals over dollars to equal reals over dollars. So my comparison has to be the same. I have to do the same thing over each other, if that makes sense. So 28.19 reals over dollar, reals over dollar. And now I can just do cross multiplication. So 28.19 X equals 100 times 5, which is 500. Now I just do a simple division. 28.19 500 divided by 28.19. And that equals 17. X equals 17.74. Now, the other way that we can do this is to figure out what that unit rate is and then solve. So the unit rate is going to be how much is 1 real to one, or how much is $1 equal to one, sorry, bleh. 100 reals equals how many dollars? So I want to figure out how many dollars equals 1 real so that I can then multiply that times 100. So if I want to figure out how many dollars equals 1 real, dollars per real. So what I'm going to do, and it's going to feel weird, I'm going to do 5 divided by 28.19. We are often tempted to do the bigger value on top when we're doing a division problem, but I need to figure out how many dollars it is so that I can multiply by 100. No, I'm sorry. I need to figure out how many reals it is so I can multiply by 100. So 5 divided by 28.19 equals 0.1774. And then I just multiply that by 100. And that equals 17.74. So this is the unit rate, whereas this is the proportion, and you can solve it in whatever way that you feel most comfortable. Questions? Comments? All right, let's move on to the next problem. Let f be a function defined by f of x equals 2x squared minus 3. And let g be a function defined by g of x equals f of parentheses x minus 1 close parentheses for all real numbers x. In the xy plane, the graph of g is a line with slope 2 and y-intercept negative 3, a line with slope 1 and y-intercept negative 3, a parabola with vertex 1 comma negative 3, or a parabola with vertex negative 1 negative 3. All right. So this is an interesting one, and I just want to talk about graphs and I forget that like just this movement hurts so bad. Okay. So when we have an original graph and we translate it, we have to keep in mind what's being translated. So if I have a graph, a parabola, and I'm translating it, I have like 2x squared minus 3. That means I'm going up or down. But if my translation is within my x parentheses, that means it's going right or left. And it's so hard to like not have a visual here. So I'm super grateful for those of you who have stuck around with me. Now, when we're looking at this, f is defined by this, and g is defined by this. So this tells me I am taking my original function and moving it to the right one, because inside the parentheses, we move in the opposite direction than what we would normally think. So in the xy plane, the graph of g is what? Well, it's not a line. So I can automatically get rid of a and b. It's not a line. So I can automatically get rid of a and b, because this tells me that we're a parabola. Now, is it a parabola with vertex 1, negative 3, or is it a parabola with vertex negative 1, negative 3? That's a great question. My original function is literally just moved down negative 3. If my new function is x minus 1, then that means I'm moving to the right one, which means I'm going this way, which means my vertex is going to be at 1, negative 3. So this is purely just understanding the rules of transformation, but they just worded it super duper duper funky. Is this question pertaining to patterns in algebra? This is absolutely algebra. I would look at your blueprint to determine if this is patterns in algebra or number and operations. I'm pretty sure it's patterns in algebra, but I don't have that memorized. But this is like functions, graphs, lines, parabolas, translations, all of that, which I'm pretty sure is patterns in algebra. It's not numbers and operations. Questions about that problem? All right, let's move on to the next problem. Ooh, y'all, this is a student misconception problem. I love these so much. All right. Use the student work sample below to answer the question that follows. Use the student work sample below to answer the question that follows. Sam is a middle school student who attempted to solve a set of decimal multiplication problems as shown in the example. Which of the following activities is best for the teacher to do to help Sam recognize his misconceptions? A, having Sam develop a word problem involving dollars and cents that will use the numbers from the exercise. B, asking Sam to look at the numbers in each problem and estimate what the answer should be. C, reminding Sam of the rules for integer multiplication and the values in the multiplication tables. D, reviewing with Sam the rules for adding decimals by aligning the decimal points. So, here is the student work sample, and he's trying to solve these problems. And the problem tells us that he has a misconception. So before I try to figure out what activity is going to best address that misconception, I need to figure out what that misconception even is. So what I'm going to do is I'm going to look at these problems and solve them and figure out what his misconception is. So 7 times 2 is 14. Oops, that's not what I wanted. Carry the 1. 7 times 5 is 35, 36. Carry the 3. 7 times 0 is 0. 3. 7 times 1 is 7. Okay. 9 times 6 is 54. Carry the 5. 9 times 4 is 36. 37, 38, 39, 40, 41. 72, 73, 74, 75, 76. Okay. 8 times 3 is 24. 16, 17, 18. 56, 57. Okay. So he has all the correct digits. So what is the misconception? I notice that in this problem, we have 2 decimal places being represented, 2 decimal places being represented, and 2. But I notice he only has 1 decimal place represented in each of his answer choices. He did not represent both of the decimal places that were represented. So this answer should have been 73 and 64 hundredths. This answer should have been 76 and 14 hundredths. And this answer should have been 57 and 84 hundredths. What he did was he just brought the decimal place down and he lined them up like you would in an addition or a subtraction problem, not in a multiplication problem. So, A, having Sam develop a word problem? No, that's not going to help him understand his misconception here. Asking Sam to look at the numbers in each problem and estimate what the answer should be. Maybe. Reminding Sam of the rules for whole number, negative number, integer multiplication, and the values in the multiplication tables? No, because he understands what to do. He understands 7 times 2 is 14, put the 4, carry the 1, 7 times 5 is 35, add 1, 36. He understands all of that. He just didn't look and see and understand what that decimal needs to do. Reviewing with Sam the rules for adding decimals by aligning the decimal place. He doesn't need the rules for adding decimal places. In fact, he's overcompensating the rules for adding decimal places. And so he doesn't need to know that rule. He knows that rule really well. So he doesn't need that rule. Why is B the correct choice? Because if he were to look at these multiplication problems and estimate their answer, then he would understand that he did something gravely wrong and might be able to catch his own misconception. So if we're doing 105 times not even a whole number, a partial number, is my answer going to be much larger than my original number value, or is it going to be slightly smaller? It's going to be slightly smaller. If I'm multiplying a whole number by a decimal or a fraction or something like that, my answer is not going to be bigger. It's going to be a fractional part of my original. So I know that I need to have a smaller answer. Same thing. 84.6 times 0.9. If I'm multiplying by 0.9, I'm multiplying by almost a value of 1, but just under that. So my answer should be almost the whole value of what I have, but just a little bit less. It shouldn't be 700 something. And so that would tell him that he did something wrong. Now, whether he could address that misconception or ask his teacher for help, that's to be determined. But the rest of these are not going to help him recognize, because all it says is helping him recognize the misconception. The rest of them are not going to help him recognize that there was even a misconception, if that makes sense. All right. We have time and energy for one more problem, because this whole like sitting up straight with a shoulder is exhausting. So we're going to do one more problem and then we will close up. Actually, we'll do two more because these are pretty quick problems. What is the value of x in the following equation? So here is a very simple, everybody needs to understand this process problem. If I am an algebraic thinker, all I'm going to do is isolate the x by doing the opposite of this. So I'm going to subtract 245 from both sides. And I'm going to use my calculator because doing this upside down is ridiculous. So 382 minus 245 is 137. But be careful because the answer is not going to be 137 because you have a negative x equaling the 137. So I have to end up multiplying by a value of -1 to get that x by itself, which equals a negative 137, which is b. What is the value of x in this problem? So these are some pretty like not straightforward problems because they're requiring a little bit more information and steps than like our typical problem. So in this case, our x is trapped in numerator jail. So I have to multiply both sides, and I'm just going to rewrite the problem so that we can all see it and work with it. So I need to do the opposite of what's being done to this entire numerator, which is division. So I'm going to multiply both sides by 5. So 3x minus 2 equals 25. Now we just do our normal steps. Add 2 to both sides. 3x equals 27. Divide both sides by 3. And, well, the right answer isn't there. Did I do that right? 3x minus 2 plus 2 plus 2, 27. 27 divided by 3 is 9. Yep. I probably manipulated this problem and just forgot to change the answer choices. So what I did was change the problem, but not the answer choices. So x equals 9. Now, if this was a problem that you didn't understand how to do, you can always, always, always use your answer choices to help you. So you could take each answer choice and plug it in for x and then solve for X. Does that make sense? All right. I am going to turn it back over to Dr. A. I will see you guys next week. Let me know in the comment box or find me on our Facebook page. What do you want to see me go over in the upcoming weeks? Because I love tailoring these problems to what you need. So let me know in the comment box what you need. I look forward to seeing you next week. Hopefully not with a bum shoulder, and I will talk to you soon. Bye, guys.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions, and I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you the coupon code, all capital letters, SINK35, that's SINK 35, that will take off 35% off any of our prep courses on our website at the Learning Liaisons. It doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today, and hopefully we'll see you next week too. Talk to you soon.